All right, we're going to go ahead and write the equation of this graph using all of our transformations. All right, so when we do this, first thing I do is identify the type of the graph. So the type of this graph is an absolute value graph. So I'm going to write that down, absolute value. And I know that when we have an absolute value, that the equation is going to have a formation of y equals to the absolute value of x. And that is the parent function. So I'm going to come over here and we say, all right, let's go ahead and type in the absolute value of x, y equals, and you can see that it takes that same form. Now, the second thing I'm going to do is I'm going to ask myself to get rid of it, is there a reflection? Okay, well, in this case, there is not a reflection, and there's not a reflection because they open in the same direction. So this is no, there is no reflection. And because there's no reflection, there's no negative a value or negative b value. Okay. Third thing I'm going to do is I'm going to say, so I've determined its absolute value. I've determined there's no reflection because it opens up in the same way. The black opens up in the same way as that blue graph there. Okay, and I'm going to determine if there's a translation. And you can see automatically there is a translation because the vertices are not in the same spot. So I'm just going to determine what I have to do to get to that blue graph. Well, if we look at it, I'd have to go over 2 and then up 5. So positive 5 and left 2. Okay. Now, when we write those translations in there, we know that, or have been working with the fact that if I write to the left, I'm going to simply just write x plus 2 and then up 5. And some people could be going right now, well, why is it positive 2? We're going to the left. Well, that means we're over here at negative 2. There's our formation, x minus. So x minus negative 2, 2 negatives make a positive, and it is x plus 2. And that's why you'll see the x plus 2 in the absolute value. Okay. So let's go ahead and check it and just make sure we are where we're supposed to be. So I'm going to come back to our graph, x plus 2. And then I'm going to go ahead and add plus 5. And you'll notice that the vertices do line up. So we are doing pretty good right now. Now you'll notice that the graphs do not completely overlap. And as a result, that tells us that there is a translation or a vertical stretch or a horizontal stretch that has to occur. Okay. So when I do a transfer, if I'm looking for the vertical and horizontal stretch, the one thing I go ahead and do is I draw in the a horizontal axis through the vertex, and I draw in the axis of symmetry. So essentially a vertical axis and a horizontal axis. Now, the other thing I do is I go ahead, the one that I'm manipulating, I look for the first perfect point. And the one we're manipulating is the black graph. So I'm going to look for the one perfect point, and that first perfect point is right there. Okay. That perfect point is going to be stretched to another perfect point on the other graph. And that's going to be really important to recognize, is that that perfect point has got to be stretched onto and correspond to one of the points on the blue one. So I'm going to find another perfect point, and boom, there it is. There is a perfect point right there. Okay. Now this is where things get easy. Once you've found that perfect point, all you're going to do is to find this stretch is you are going to count horizontally. Oops. You're going to count horizontally, which would be, in this case, 1, 2, 3, 4. That would be our horizontal. And then we are going to count vertically. 1, 2, 3. Okay. And those are going to be our stretches to get this point to correspond to that point. So our vertical stretch is 3, which is going to be our A value. Our horizontal stretch is 4, which is going to be our B value underneath the x minus. So in other words, I'm just going to write it as y equals 2, or I'll just write it here, y equals 2, our vertical, which is 3, x plus 2 over the horizontal, which is 4, plus 5. So let's go ahead and check out if that works. So I'm going to put a 3 in the front. That stretches it a ton. And let's see what that 4 there does, divided by 4. And plus 5. You'll notice automatically that the black graph now overlaps the original graph we had. And as I said before, we determine what type of graph we're dealing with. We determine if there's reflections, what the translations are occurring, and then we have to determine our stretches. Once they overlap, you have got it figured out.